So hi guys, this is the project teaching case for my project that I've developed, and that is automatic coin sorter. So the current industry problem regarding the coin sorter is that we have to manually sort the coin denomination. For example, 5 cents, 50 cents, $1, $2. And this can be a lot of work, and it becomes a mess when the store is quite busy and the customer line is increasing waiting for their turn to check out. So the current coin sorters that we have available in the market that we can buy online, sort coin based on this physical characteristics like size, weight, thickness, and they can be easily fooled with an item with a similar physical characteristic, means which is not a coin. So I feel like that there is a need to add one more layer of authentication, which can be image recognition. So my proposed solution to this was that through this project, I'm aiming to develop a coin sorter that uses image recognition through the process of machine learning to identify coins of different values. So when the coin is identified, it is sorted into its respective coin value compartment. So how am I going to do this? So this is a brief. This is just a short summary, and I'll be going into details in the later stages of the presentation. So I'm going to use a 5 megapixel camera module of Raspberry Pi to take the picture of the camera. And the programming language that I'll be using is Python, and the version that I'll be using is Python 3.7. And I will be training the classifier with a set of images of different coins, like for 1 cent. So for this project, I have trained 4 different coins: 5 cents, 10 cent, 50 cents, and $1. And I have trained the classifier with the images of all these coins in different lighting condition and in different orientations. So when the coin is dropped into the machine, first it will be dropped onto a conveyor belt, which will be powered by a dual shaft gear motor. As the coin goes through the belt, the camera on the top of the belt detects the coin, and at the end of the belt there will be a 4 compartment setup powered by a servo motor. So the picture of this 4 compartment setup is provided in the later stages of the presentation. So this setup will set into position on the identification of the coin, and when the coin comes to the end of the conveyor belt, it will fall right into the correct compartment. So this project is let me begin with the tutorial of this project. So this project is divided into 3 categories, and the final working prototype is made by combining all these 3 categories. So the first category, or the initial phase of the project, is the training of the coin dataset and the recognition of the coin inserted by the user by the Raspberry Pi camera. And the second category is the conveyor belt that takes the coin dropped from the user and passes it below the Raspberry Pi camera module and then to the sorting compartment storage. And the third category is the sorting mechanism powered by the servo motor, which is connected with Arduino. And the Arduino in this case is connected to the Raspberry Pi, and it waits for the signal from the Raspberry Pi, and then based on the signal received from the Raspberry Pi, it then gives command to the servo motor to change its position. So let's talk about the first phase. So the first phase is coin recognition. So for the purpose of coin recognition, I have used a software called OpenCV. OpenCV is a software that is used for image recognition and contour detection. And it is all done on the basis of machine learning. And now in the next slide, I'll be talking about the steps of installing OpenCV on a freshly installed Raspberry Pi operating system. system. So these are the steps. So firstly, on a freshly installed Raspberry, you have to first run some commands in the terminal to install some dependencies. So as you can see, first you have to update the Raspberry Pi operating system so that all the recent functions, all the recent update, all the latest update is functions are into the Raspberry Pi, and then you have to run the command to upgrade that. And then you have to use the sudo apt get install command to build the essential configuration by using the third command. And then you have to install some libraries that will be used in the later stages of the that will be used in the coin recognition mechanism of this project. So these are the libraries. Means the libraries are listed here. These are all the libraries like libavcodec, libavformat, and libpng. Is for working with PNG files. JPEG is working for JPEG files, and lib264 is for working with pixels, and these all are the libraries that need to be installed. So you have to install these library one by one as directed in these commands. So then you have to then we'll be proceeding further with the installation of OpenCV. So first you have to go to the desktop, and you have to first download the zip of OpenCV and OpenCV contrib. The version that I'm using is 3.3.0, and I think you should also use this version because the code that I have written in this used in this project is related to this version. So first you have to download it, and then you have to unzip both the files. So for the purpose of this project, I've used virtualenv. So virtualenv is used for the purpose to separate all the libraries and dependencies installed for the purpose of our project from the actual operating system. So all the libraries means everything that we are installing on a virtual a virtual environment. So if the libraries that are installed on the virtual environment, if they are used outside the virtual environment in the operating system, it cannot be used because they are installed in the virtual environment. And this is the purpose of using a virtual environment, so as not to mix the libraries and all the stuff from the operating system libraries. So for this you have to use these commands to install virtualenv and virtualenv wrapper, and you have to make some changes to the configurations as told in this, as directed by these commands. And then you have to, once installed, then you have to make the virtual environment of the Python 3 version. And after entering into the virtual environment, you have to install NumPy, sklearn, SciPy, and matplotlib. These will be used for our coin detection mechanism later on. And now after these are installed, we'll install OpenCV. So first you have to change your directory to the OpenCV folder, and then you have to make a folder called build. You have to go inside the build, and then you have to make some changes to the configuration by using the cmake command, and you have to include all these lines of code till build examples is equal to on. And then after building everything, you have to use the make process. So this thing will set the mode into compilation mode, and this process generally takes about 3 to 4 hours. So you can sit back and relax and have watch a movie or have a cup of coffee. So after 3 to 4 hours, you have to install, after the compilation is done, you have to install the you have to first make you have to install the OpenCV. Sorry, you have to install the OpenCV, and after the installation, you have to rename some files as directed here for it to work perfectly. And after renaming, congrats, your OpenCV is installed is now ready to use for our project. So as OpenCV is installed, we are now ready to train the Python classifier with a set of images of different coins. So as you can see on the right side, uh, this is a code of me uploading the images that I captured of different images of different coins to the classifier. So as you can see, I have created an enum for different coins. So the as of now, this is just 3 coins, but in the actual code I have used 4 coins. This is not the latest version, so just add one more coin as per your requirement. So I have created the glow function. I've used the glow function to upload the files, and then I have used the trainings. Then I'm uploading the histogram of these the histogram function of these coins into the training data set. And on the right, as you can see, this is one of the sample image of the coin that I've used. So this is a 50-cent coin and this is a $1 coin, and I have uploaded like 40 to 50 images per coin in different orientations and in different lighting conditions, so that the coin can be recognized in whichever orientation it is dropped in. And here in the code that you can see that I am training the test and the I'm training the data set into the classifier. Okay, so this a piece of code is very important for our project as well. And in this piece, I'm identifying circles by first turning the image captured by the camera into a into first converting the image into black and white or gray color, and then after turning the image into black and white, I am blurring the images so that the circle can be detected. And once these circles are identified, the contours of the image is then made. And this was the main the code that has had to be explained, and the rest of the code is pretty self-explanatory. Means there's the rest of the code can be pretty self means it can be understood very easily. So I'm going to skip for that part because I have to complete the presentation within the time limit. But I have uploaded the code to my GitHub, and I'll be providing the link in the presentation as well. So for this project, I have used a cloud function as well, which is called Twilio. So Twilio is an application that is used to send messages from your computer to your mobile devices. So in this project, I'm using Twilio to send messages from Raspberry Pi to my WhatsApp number through internet or cloud. So how this works is, as soon as the coin is detected by the Raspberry Pi using the camera, it sends a WhatsApp message to my number notifying me about which coin is detected. So as you can see on the core on the right hand side of your screen, if the coin detected is 50 cents, so first first it adds to the total of 50 cent, and then it writes to the Arduino that 50 cent has been detected, and then it sends a message to my WhatsApp number saying that 50-cent coin detected. And the same goes for $1.05 as well, and the other coin as well, the fourth coin as well. So this is how it works, and here are the steps to set up a Twilio a function for this project. So first you have to navigate to twilio.com. You have to sign up for an account, verify your number. Then you have to navigate to SMS chatbot, give a suitable name to your project. Then you have to navigate on the left hand side of your screen. There is a programmable SMS category. You have to navigate to that. Then you have to go to the WhatsApp category, and you have to activate Sandbox by clicking the checkbox and agreeing to the terms. Then you will be presented with a WhatsApp number and a code. So you have to send that code on the screen to the WhatsApp number provided, and once you send that successfully, you will be added to the you will be added to the Twilio database. And once your number is added, you have to navigate to the console, and you have to copy your account SID and authentication token. And once you have copied that, you have on your RPi, you have to first install the Twilio library. So fire up the terminal on the Raspberry Pi, and then use the command pip install Twilio to install the library. For if you want to install the Twilio for Python version 3, then you can use pip3 install Twilio. So once the library is installed, in your the code that you in your Python code, in your coin detection code, you have to first include the library. So you have to use this command from twilio.rest import client, and then you have to specify your account SID and your authentication token. You have to write your account SID and authentication token that you copied from the previous website. And then you have to take the code from the previous slide, and congrats, cloud connection is established. Okay, so the second phase of my project is the conveyor belt. So the conveyor belt in the system is responsible for carrying the coin inserted by the user into the camera to be identified, and then to the sorting storage mechanism. The conveyor belt system consists of two or more pulleys with an endless loop system to carry the things. By using this concept here, I have made the conveyor belt with simple material like the motor and the cardboard sheet. So these are the materials that you will be requiring: dual shaft gear motor, a 3.7 volt battery, a cardboard sheet, a glue, a knife, cycle tube, PVC pipe, and a cycle spoke. So these are the steps that you have to follow to make the conveyor belt, and these steps are pretty easy, and I think you once you read through the steps, you'll be easily able to make the conveyor belt. So these are the steps here as well. These are the second phase of steps, and as you can see, the steps are pretty easy, and once you are done with these steps, your conveyor belt will be ready. So this phase was the easiest phase, I think, because there was nothing, because this phase was entirely dependent on arts and craft, and no coding was involved in this phase. So the third phase of my project is the servo motor and the coin sorting mechanism. For this purpose, I have used Arduino to operate the servo motor. The Arduino in turn collects the signal from the Raspberry Pi and then turns the servo motor based on the coin identifier. So right hand side, as you can see, is the connection that has to be established between the servo motor and the Arduino. And it is pretty easy. There are only 3 connections that have to be made. So the connection between the Arduino and the Raspberry Pi is done using a USB cable, and the communication that is developed between these two systems is the serial communication. And when the coin is identified by the camera paired to the Raspberry Pi, the Python code that we discussed earlier sends the signal to the Arduino via serial communication, and this signal is sent in bytes, so we have to be careful for the conversion as well. So for this connection to be to happen, first we have to install the Arduino IDE on Raspberry Pi, and once that is installed, we have to upload the code that is given here to the Arduino. So once we upload this code to the Arduino will be set into waiting mode. Means it will wait for the signal from Raspberry Pi, and whenever a signal is received from the Raspberry Pi, it will change the position of the servo motor based on the signal. So this is the first piece of code, and it defines the pins associated with the servo motor and defines the serial connection between Arduino and Raspberry. Then it checks for the connections. If the connection is established and the signal received is $1, meaning a $1 coin is identified, it sets the position of the motor to 0 degree angle. So this is the initial phase. So in this piece of code, this is one of piece of code of the four pieces of code, four different pieces of code. So this one focuses on the if the coin previously detected was 50 cents. So meaning the servo motor is in the position that it is receiving a 50-cent coin from the belt. So if it's in that position and the signal and the next coin detected is, let's say, a 5-cent coin, then the servo motor will rotate by 90 degrees so that the 5-cent coin compartment is aligned with the motor, and the 5-cent coin falls into the 5-cent into that compartment. And the same mechanism goes for other coin values as well. So depending on the position of other coin compartments, I have defined the angles. So for $1 it is first 270 degrees, so first it will rotate 180 then 90, so that $1 coin compartment is at the front. And same goes for 10 cent. I've rotated the servo motor by 180 if 10 cent is detected. So this is how my setup looks like. So as you can see, there are four boxes here for storing the coins. So there's a there's a $1 box, a 50-cent box, a 10-cent box, and a 5-cent box. And these are cardboard boxes, and the popsicle sticks serve as a base for these boxes, and everything is glued to each other by using a super glue, so that the connection is the setup is firm and it does not break easily. The popsicle sticks are taped to the servo motor wheel. The servo motor ends, means there are four ends of the servo motor axle, and the popsicle sticks are taped to them. So this is the end of the third phase as well. And so I have made this project to satisfy the condition of a high distinction criteria. All the high distinction criteria conditions are met in this project. So the project idea is presented with using a fully working prototype, and at least two systems have been incorporated in this project. So this condition has been satisfied as Raspberry Pi paired with RPi camera module is connected to Arduino via serial communication method, and Arduino is in turn connected to the servo motor. So the system aims to solve a real life problem, which is sorting the coins based in a supermarket or a shop. The prototype also reacts on environmental conditions, that it reacts differently to which coin is inserted. Means if the coin inserted is $1 to 50 cents, the messages sent are different, and the servo motor is then the position of the servo motor is changed differently. And the system is responsive, it works very fast, and as soon as the coin is detected, the servo motor is changed, the position of the servo motor is changed. It's real time, everything is happening in present time and real time. And it is multi-threading as well, as the conveyor belt motion in this project and the detection of the coin are happening simultaneously. And the project is the prototype is robust as well, as everything it has been fixed using a super glue, and it is made sure that the project is strong, means it is not easily broken. And much focus is given on the design of the prototype, and the project is made to be well presented. So in conclusion of this project, everything that has been discussed is required for this project, and nothing is means everything is important. And the equipment alignment at the end of the project should be like this. So the camera paired with the Raspberry Pi should be pointing downwards perpendicularly at the conveyor belt, and if the conveyor belt is at an angle of the camera view, it may cause some problems for coin recognition. So it has to be perpendicular, means the coin surface and the Raspberry Pi lens should be parallel, and the servo motor compartment, as shown in the last slide, should be at end of the conveyor belt waiting for the coin to drop in. So I think you can imagine how this should be happening, and I would uh, uh, show a working prototype of this project and later. Things that should be kept in mind while making the project. So the conveyor belt's material should be gray in color if possible, as it makes the image recognition faster and easier. Super glue should be used for pasting cardboard sheets, PVC pipe, and everything else, as it makes the prototype more stiffer and robust. And lighting conditions should be good for image recognition. So you should prefer to use a torch pointing at the place where the camera detects the coin, and careful not to shine the light too close to the coin, as it will make the coin detection difficult or may even cause failure. So thank you guys. This was my project teaching case, and I hope that you will be able to follow these steps and make a fully working prototype. Thank you so much.